very warm welcome from expertworks, Big Data and Hadoop course. I'm your instructor Navdeep. Little background about me: I have worked at major companies like HCL and Infosys Systems. We have over the years architected, designed and developed multiple innovative and high-performance large-scale solutions such as distributed systems, big data management tools, SaaS cloud applications, and also data analytics solutions. We are really excited to have you on board for this course. Now, this course has been particularly designed based upon industry standards, so anyone looking out for jobs later on after completing the course can do so confidently without any hiccups, as you'll be trained on what kind of problems you'll be solving in the real-time industry. In this particular introduction tutorial, we'll be discussing about the course structure, how will we be proceeding throughout the course, and also after discussing the course structure, we will be talking about a little bit outline of big data. So let's get started. So throughout the course, this course has been divided into segments. There is learning part that will contain all of the lectures. Now, in order for us to make sure that you retain all of the learnings that you get throughout this course, we have added a few more sections that will make this course a bit more interesting, and you'll be able to solve problems by your own. So there will be some short question and answer assignments based upon the learning, based upon the lectures that we will be conducting. After the assignments, there will be some technical logic building questions that will help to build a good formation for logic. Then there will be some lab exercises which will contain some coding assignments, so a little bit practical that we'll be having, and some mock tests that will help us boosting our straps, and that can help us bring all of the concepts and ideas and learnings on board. And after all of this is over, there will be some mini projects that will help us learning a bit more, and also will help us identify what kind of mistakes we were making, and will help us build some concrete practical tasks. Already excited to proceed with the course? Let's get going. So first of all, what is big data? So big data in its purest form is basically a word that is used to describe massive amounts of storage or volume that is big. It could be structured, it could be unstructured, it could be a mixture of both structured and unstructured, and in fact it's so large that traditional database management techniques just seem to be failing over in trying to handle the kind of data. So big data, just as the word sounds like, is a whole lot of data. Now, applications of big data. What are some of the applications that we could do, or what can we possibly do with a lot of data? If you ask me, Well, we can place that in a data warehouse, and we can denote some keywords, and possibly we can create a search engine just like Google for finding out lots of big data, lots of data, inside data. So it's easier to find out a book from a library rather than manually looking for a particular book in a particular section of the library. You directly just type the name of the book and the book is right there in front of you as soon as you press enter. You can create a whole lot of things. You can create social media, you can do weather predictions, you can do science and engineering, identifying the structures of the molecules. You can do some image analysis upon the pictures. You can do astronomical analysis to find out more about the universe, like new discoveries, inventions, lots of stuff we can do. It can help us in the medical field, identifying diseases at an early stage with a lot of data, with a lot of data of the DNA. The kind of hereditary diseases could be diagnosed early in the age rather than when it's too late. So there are lots of uses of big data, and it can transform the world around us. Even today, what we see all around us in different electronic mediums is a lot of data. It's big data, in fact. On Amazon, eBay, Walmart, Facebook, Twitter, it's all big data. Then we talk about who are the users of big data. Well, the information technology are the users of big data. There is research and development who are also using big data for their research purposes. Then there is salespeople looking to organize data and find out what could be the possible lead. There is the marketing department looking for big data to identify the kind of market that they should target. Then accounting and finance department, customer service, and human resources. It's an all-round field. Big data can be used anywhere if applied correctly, and it could be profitable for you. So some prerequisites which we recommend you to be having before proceeding throughout the course. Just don't worry if you are not aware of the prerequisites. You can still go on. Some things during the lectures might not make a lot of sense to you in the beginning, but hold on and things will start to get clearer as soon as you proceed. So first of all, there should be an understanding on the basis of big data. This is not a definite requirement to learn the Hadoop framework. We will be proceeding and learning each of the framework that Hadoop involves. But it's a good idea to have a little bit base about what we are stepping into. Then the second thing is Java. So Hadoop is written in Java. You need to at least have a little bit basics of this programming languages to get your hands dirty with. There's no need to be disappointed if you don't know Java or you are from a totally different background. There are still lots of opportunities to work on Hadoop, as there are growing opportunities in the field of big data. The third one is Hadoop is basically running on Linux for yielding better performance over Windows. Considering that basic knowledge of Linux will be suffice or will be more than sufficient. Just a little bit of knowledge about UI, UX, how you can move around and do some basic tasks on Linux, like moving a file, creating a file. If you know these commands, these are more than sufficient. The rest of them we'll be covering throughout the course. Now comes the interesting part, the V's of big data. So these are known as the pillars of big data. These are defined as volume, which is basically the big criteria. With the dramatic growth of internet and mobile devices, social media, Internet of Things technology, the amount of data that is being generated through all of these technologies has also grown proportionally. Also, this has impacted the velocity. If we consider this closely, that the amount of data that is being generated is also increasing. Then the variety of data also, in case of different types of data, say there are photos on Instagram, there is say texts, say statuses, there are tweets going on Twitter, there is backend server data, there is like geo coordinates, geographical data, lots of variety of data, structured, semi-structured, unstructured. Also, the variability, meaning of words in unstructured data can change based upon the context. Say there are two words which are meaning the same, like there and there. So the meaning behind certain words can totally change based upon the context that we are referring to in that particular sentence. Then there is veracity, with many different data types, many different sources, many different data quality issues also pop up in big data sets. So we basically deal with them in a systematic way, that is cleansing the data before analysis. Because if we do analysis on noisy or dirty data that is not properly cleaned, the results that we get from the data will also be noisy or won't be that accurate. The kind of accuracy that we are looking for won't be there. Once the cleansing process is done, then we can visualize the data, creating some beautiful bar graphs, pie charts, some beautiful visualization techniques we can use to get some more insight. After getting the insight, we can extract the value, the real thing, the real gold that we have been trying to extract. So once all of that process is completed, then we can extract the value. So what's the difference between structured, semi-structured, and unstructured data, which we have just been discussing about? So it turns out structured data is the kind of data that is structured in columns and tables, that is properly fitted into rows and columns. They have relational keys and they could be easily mapped into, say, pre-designed fields. Today, the kind of data we most get is structured data, and being as it's also the most simplest way to manage data and information. So that's structured data. When there are some information missing in structured data, we call it semi-structured data. An example is XML files. Any of you coming from SQL background, from relational, who has studied relational databases, data warehousing, will be acquainted with the fact. Also, HTML background students would be aware. The XML files, so these are semi-structured data. And then when we come to photos, videos, text, media logs, server logs, that is unstructured data. Data that is not structured properly at all. That is not organized in a predefined manner and does not have a predefined data model. That is, it's not a good fit for mainstream relational databases. But how big is really big data? Now, how big of a task could it be? Like, we have been learning about tools, new techniques. We have been trashing the old traditional ways of storing database and managing that. We have been finding new ways to store and process the data. But how big could it be? So some common units of measuring data, we firstly have bytes. Data is usually measured in bits and bytes. As it gets bigger, we refer to it as kilobytes. Then as kilobytes get bigger, we call it megabyte. As megabytes get bigger, 1,000 megabyte becomes a gigabyte. Then 1,000 gigabyte becomes 1 terabyte. 1,000 terabyte becomes 1 petabyte. Then exabytes, and then zettabytes. So estimatedly, we have around 1 zettabyte of data as of 2016 Cisco survey. Considering data doubles every 2 years, and we are currently learning Hadoop in 2021, so we can expect that we are having around 4 zettabytes of data as of now. Sounds big, doesn't it? It's pretty big. Is equal to 1 zettabyte is equal to 1,000 exabytes, 1 billion terabytes, or 1 trillion gigabytes. 5 trillion gigabytes is the amount of data that is estimated to be present as of 2021. That's a lot of data. Especially if we take into account that internet is not even 40 years old. So Cisco also estimated that by 2020 the annual traffic will grow over 2 zettabytes. In fact, they were little lesser. It has grown over 2 zettabytes. It's a lot of data. So whom can we credit for this kind of growth that has happened in big data over the years? So data is generated by not just the internet, but also the research and development department. The satellites moving around the earth are also capturing data. The aviation department, air traffic management control, social media, we have discussed about it, mobile devices, our cameras produce data. While we are texting someone, we are receiving a call, we are generating data, remote sensing. software logs, Internet of Things, smartwatches. These also produce a lot of data. Then stock exchange and finances. Well, here data is getting produced every second. Every second there's either an up or down in the market. Something has changed, so the data has also changed. Then online shopping and e-commerce stores also produce data. There is radio frequency identification readers that produce data, or RFID readers, sensor data, astronomical data, scientific and engineering data. Lots of data all around us. And in different forms. We are having huge volumes, high velocity, and that is also structured into different forms of data. There is structured data, that is relational databases. There's semi-structured data, our XML files. Then there is unstructured data, that's photos, videos, documents, PDFs, text, etc. A whole lot of data. So there, now it becomes a problem. That if we're talking about that how much data is created every day, it is around 1.14 trillion megabytes per day, or 2.5 quintillion bytes of data is created every day. And this number has been increasing in order ever since. So as we were discussing the internet producing data, our mobile communication, text messages, producing a whole lot of data. And organizations are also changing policy regarding how they manage our data. Talking about just the speed, talking about just the storage, for data to be useful, it's not just enough to store it. You have to be able to access it and process it. Then only you can say that, okay, you are having some ready storage, like a bank. Whenever you want, you can go and access your money, and whenever you want, you can deposit the money. It's under your control. It's not like, okay, like in the middle of night, you require money and you can't access it. There is an online server that lets you access your money 24/7, even when the bank's closed. So that's also big data. You have to access it and process it. Now there are 1 million users who could be using the same bank, and the bank cannot afford to be offline for any minutes. So one can measure the computer power either by number of instructions per second, or IPS, or we can also calculate or measure it in form of floating point operation that are being processed per second. This is also known as flops. So the kind of processor that we are having right now on our computers is gigaflops. Now to access and process huge amount of data, you need petaflops of power. That is 1,000 of teraflops should be there. So according to statistics, 95 million new posts are created on Instagram every day. Now all of this data can make it a whole lot more difficult to analyze it, that there is so much data being produced every day that it's even hard to keep track of it, forgetting about analyzing and stuff. in creating insights from the data. First, we have to be able to store and process this data for us to be expecting any insight or any value out of it. And the analysis of Instagram and other social media offers numerous benefits for marketing. However, big data is only useful when you actually use the information about all of the interactions. So on this or until we are not using the data, there is no value out of it. So I hope this was an interesting lectures for you guys. We are really excited for the coming lectures. I hope you guys enjoyed this tutorial. See you guys in the next tutorial, where we discuss some basics about relational database management system, which were the key database keeping technologies during the earlier 1980s, 1970s, when database had just started, and what were some of the major problems that relational database management system has, and how can we overcome it in big data technologies. So much excited to take you through the course. See you guys in the next lecture. Happy learning.